Hi everyone, welcome back to another video. I hope you're all doing well, and in this video what we're going to be looking at is surds, and I've written down part 1 because surds is quite a big topic, okay? And in this particular video we're just going to be exploring what the definition of surds is, okay? So let's jump straight into it. Okay, so to start off with, what I want you to do is have a think about these numbers that I've just written down, okay? So we've got 15, oopsies. So we've got 15 here, 0.5, 0.5 recurring, 3/4 and 0.142857, okay? Where the 1 and the 7 are recurring. What I want you to do is pause the video here, okay? Have a think about these particular numbers and see what you can find is common between all of them, okay? And then of course I will share what the answer is. Okay, so hopefully you had a go at thinking and brainstorming what these numbers actually are representing, okay, or what they all are a part of. Now, I'm just going to go through what they actually are. So you might have actually heard of the term rational numbers, okay? If you know that, that's great, because that is what is really going to help us understand what a surd actually is, okay? So let's actually think about rational numbers. They are numbers, okay, that can be written as a fraction, okay? So we all know what a fraction is. So a fraction is just 3/4. We've got an example here at the top, okay, or a half, or 2/3. Okay, etc. Now, what I mean by rational numbers is it is any number that can be written as a fraction, okay? Okay, so examples include a whole number. Okay, I'm just going to write down NO for number. Now, a whole number, we all know, or some of us do know this, that it can be written as an integer, okay? Sometimes called an integer or a whole number, they are the same thing. So, rational numbers, they are whole numbers, okay, or integers. They are also terminating decimals, okay? We will look at examples at the top that we've just got, okay? So don't worry about that. And there's also recurring decimals, okay? So these are the 3 versions of rational numbers that we can get, okay? Now, all of these 3 types can be written as a fraction, okay? So I'm going to just go back to my list at the top of numbers and go through why each of these ticks the box for rational numbers, okay? So let's start off with number 15 first. Now, number 15, okay, is a rational number because if we go back to our definition, it is a whole number, okay? So hence it is a rational number. And then if we look back at 0.5, well, that is a decimal, but what type of a decimal is it? If we look back at our examples, well, it is a terminating decimal, okay? And by terminating, what I mean is just the fact that it stops, okay? It stops after a certain point. So this decimal stops after the 5 and does not go on forever. So hence it is a rational number, okay? Because I can write that as a fraction. What is it as a fraction? We know 0.5 is a half, okay? And also let's go back to 15 as well. That can also be written as a fraction because remember, whole numbers, you can just write them over 1, okay? So 15 divided by 1 gets us back to 15. So hence it can be written as a fraction, and it is a whole number as well, so it is a rational number. And then going back to 0.5, well, that's a terminating decimal and can be written as a fraction, so as a half, okay? Hence it's a rational number. Now 0.5 recurring, okay, it is a recurring decimal, so it is a rational number, and it can be written as a fraction as well, because if we were to type 0.5 recurring in our decimal and then press the SD button, then we would be getting 5/9, okay? So hence it is a fraction, it can be written as a fraction, so it is a rational number. Then moving on to 3/4, well, that is already a fraction, so we don't have to do anything there, okay? So hence it already ticks the box for us for a rational number. And then lastly, we've got 0.142857, and the 1 and the 7 parts are recurring. They've got the recurring dots, which means that this whole 1, 2, 3, 4, 5, 6, we've got 6 digits here after the decimal point. They are all going to keep repeating, okay? So after the 7 we're going to have another 142857, and then so on, okay? And it just doesn't stop. So that's a recurring decimal, and again that can also be written as a fraction, and if you were to put that in your calculator and press the SD button, you would get 1/7, okay? So hence these are all what we call rational numbers, okay? Now, do other number types exist? Well, certainly they do, okay? In maths we have got quite a lot of different types of numbers that we come across. But in this particular video, we're going to be looking at surds. So I'm just going to show you what surds are, okay? Okay, got another task for you before we actually finally move over to looking at what surds are. I want you to list the first 15 square numbers, okay? So pause the video here and have a think about square numbers, what are they, and what are the first 15 in particular. Okay, so off you go. Okay, so these are my first 15 square numbers, and by square numbers, okay, what we actually mean is a number. So for example, if we think about 3, and if we square it, which just means 3 times by 3, then we get the answer 9, okay? So that's what a square number is. So 9 is a square number, 16, 25, and all the numbers I've listed here are square numbers. So this is 15 squared, okay? So that's all of our square numbers. Now these are quite important. I would like it if you could memorize these if you already haven't, okay, because they're really going to help you to later on solve and simplify surds, okay? They come in a lot in this topic. Now I want you to think about the square root, okay, of these numbers. So I've already talked about 9, and the square root of that is 3, because 3 times by 3 gives us our 9. Now, what if I told you, or what if I asked you, what is the square root of 16? Okay, well, the square root of 16, we need to think about a number multiplied by itself that gives us that. Well, that is 4, okay, because 4 times by 4 gives us 16. So then if I ask you, what is the square root of our next square number, so 25, okay, square root of 25, well, a lot of us do remember this one because it's a nice and easy one. It's 5, because 5 times 5 gives us 25. What if I asked you, what is the square root of, let's say, 20? Okay, what would we think then? Okay, well, in our list, if we go back and check of our first 15 square numbers, we don't have a 20 here, okay? Hence 20 is not a square number. But if I want to work out the square root of it, what do I have to do, and is there an answer for that? Well, there is an answer. If I put that in my calculator, okay, I would get a number, but that would be going on forever. It's not a terminating decimal, and it's not a recurring decimal. Hence, these certain types of numbers are called surds, okay? So this is an example of a surd. So the square root of 20 is a surd because it does not terminate, okay, the answer, and it does not recur either, okay? It's not a rational number, hence we call it a surd. And another way of thinking about it is what we've been looking at before in the previous, at the start of this video, was rational numbers. So this is also an example of an irrational number, okay? And by irrational, remember, I just mean it's the opposite of rational. So it means that it's a number that does not terminate, okay, and it never starts recurring, and hence we can't write it as a fraction, and therefore it is a surd. Now I just want to go ahead and actually write down the proper definition so that you can copy it in your notes, okay, and always refer back to it. So the definition of a surd is that it's the answer to a root. Now that root, it could be a square root or a cube root as well, okay? So by cube numbers, remember, we mean things like 3 cubed or 4 cubed, and it's just doing 3 times by itself 3 times, okay? So So the cube root is just, for example, 3 times by 3 times by 3, which gives us 27, okay? So now 27 is a cube number, and the cube root of 27 is 3. So, yeah, what I was saying was that it's the answer to a root. Now that could be a square or a cube root, which is an irrational number, okay? And irrational is what we just went through in the previous section. Okay, so hopefully that makes sense, and I will also just write down some examples of surds and also some non-examples, because they really help us to identify clearly what a surd is. So examples are for surds are, we've got the square root of 5 and the square root of 23. And now these are surds, remember, because they don't actually have a square root, which is a rational number, okay? And then non-examples of surds include square root of 4 and a square root of 100. Okay, so these are not surds because the square root of 4 is 2 and the square root of 100 is 10, so we can actually work them out, okay? So they are rational numbers, hence these are not surds. Okay, so I've got a couple of questions for us to think about. Which of these are surds? So now I want you to go through each question, okay? Solve it and think about, are these surds or not? So you can just put a tick next to the one that are surds and a cross next to the ones that are not surds, okay? So pause the video here, have a go at this, and then come back to it, and I will go through the answers. Okay, so the first one, let's go through it together. The square root of 10. Now this is a surd, okay? Because the square root of 10, remember, does not exist. It is an irrational number, okay? If you put it on our calculator, you'd get a long decimal number, okay, which goes on forever. So hence it is an irrational number, so a surd. The next one, we've got the cube root of 8. Well, the cube root of 8 does exist, okay, and that is 2, because 2 times by 2 times by 2 gives us 8. So hence this is not a surd, okay. Next one, we've got the square root of 4. Well, that does have an answer, okay, which is 2. So hence again that is not going to be a surd. Let me just get my pen. So the answer is 2 again, so hence it is not a surd, okay. Next, we've got the square root of 121. Again, we can solve that because 11 squared, okay, gives us 121. So this would not be a surd because it's a rational number that we've got as our answer. Next, we've got 27's cube root. Well, if we think about that, that is just 3 times by 3 times by 3. So hence, that again is not going to be a surd. Okay, and then if we move over to these ones, we've got the square root of 16. Again, that is 4, so that's not a surd. Then we've got the cube root of 25. Now that's an interesting one. 25 is a square number, okay, because the square root of 25 is 5. However, it is not a cube number, so hence this is a surd. Let's just get our green pen. Okay. So I like to just keep my greens for ticks and my reds for crosses. It's just the teacher in me. Okay, so the cube root of 25, I said, sorry, that it does not exist, hence this is a surd. Okay, next we've got the square root of 1. Well, that is actually 1 itself. A lot of people don't, count 1 as a square number, but it is. And they forget that, so that is not going to be a surd, okay, because it's got an actual answer, a rational number. Now the next one, we've got the cube root of 64. Well, that does exist, okay. 64 is actually a square number as well as a cube number, okay, because 4 cubed, 4 times by 4 times by 4 gives us 64, so this would not be a surd. And then lastly, we've got the square root of 2, okay? Now this one, it does not have a rational answer, so hence this one will be a surd, Okay, so there's my tick for that one. Now these are all of the answers, okay, for this section, and I hope that it made more sense to you what a surd is. Okay, so before we actually jump into the harder videos, tutorials about rationalizing surds or simplifying them, and doing calculations with them, it's really important that you understand the basics, which is what on earth is actually a surd. Okay, so it's quite important. Okay, so just to reiterate what a surd is, it is the answer to a root, and now that root could be a square root, okay, or it could be a cube root as well, okay, and it's the answer is an irrational number. And by irrational, what we mean is that it is a decimal that doesn't terminate, okay, doesn't stop, and it never starts recurring either. So hence, it can't be written as a fraction, okay, and therefore it is an irrational number and hence a surd. Okay, so that brings us to the end of the video. I hope you enjoyed it, and if you did, please remember to give it a thumbs up. Okay, subscribe to my channel for more videos, and also follow me on TikTok. Okay, and I'll see you in the next one. Thank you, bye bye.